So today's topic is going to be trinomial of the form x² plus bx plus c. In this case, of course, a trinomial is composed by three terms. How to look if a trinomial is a perfect square trinomial or an x² plus bx plus c? Well, the first term, of course, has an exact square root because x² has an exact square root, so that's same as perfect square trinomial. But in this case, we can have a third term that doesn't have an exact square root, and maybe the middle term, it's not the double product between the square roots of the first and the third term. So that's how we can check if our trinomial can be a perfect square trinomial. If not, maybe it can be a trinomial of the form x² plus bx plus c. Of course, in this one, we need to have only a 1 with the x squared. That's why it's called only x² plus bx plus c. So we need to have a number 1 there. The answer of this kind of exercise will be called binomials with common terms. So it's going to be the opposite of the special product. Remember, factoring is the opposite of a special product, so we will get binomials with common terms. The steps for this type of exercises. It can get a little tricky if we only look for the steps, but actually when doing an exercise, we will see that it's going to be very easy. The first step, we need to order the trinomial to have the structure x² plus bx plus c. So if it's not correctly ordered, we need to order it. Then we will open two parentheses. On the first one, open one parenthesis with the square root of the first term and the sign of the bx term. That means this specific sign. So we will get the square of the first term and the sign of the bx term. And what happens with the other parentheses? In the other parentheses, we will have also the square root of the first term. And what about the sign? It says the sign we need to obtain the term c when multiplying by term bx. So here I got a positive one. What do I need to multiply to become a positive? Well, another positive. What happens if c was a negative one? Okay, a positive to become a negative must be multiplied by a negative. So it will be that way. Which sign we need to obtain the term c when multiplying by term b? And finally, step number 4 says, look for two terms that when they get added or subtracted, that means an algebraic addition, when they algebraically being added, we get the bx term, and when multiplied, we will get the c term. So as I was telling you, if we saw only the steps, it will be kind of difficult to imagine how to do it, but if we do a specific exercise, we will see that it's very easy. So let's go with today's examples. So imagine we have something like this, x² minus 24 minus 5x. So the first step we need to do is to order our trinomial. So correctly ordered, it's going to be x² minus 5x minus 24. So in this case, I will open up two parentheses. I know that it's not a perfect square trinomial because 24 doesn't have an exact square root, so it's an x² plus bx plus c trinomial. So I open up two parentheses. Remember, I will put this actual root on the two terms or on the two parentheses. Then it says the first parenthesis will have the sign of the bx term. What happens with the second parenthesis? Remember, we need to check minus to become a minus term. We need to multiply it by a plus term, because if we multiply minus by plus, it's minus. So now we need to look for two terms that when they get added or subtracted, we get minus 5, and when multiplied, we get minus 24. So in this case, if I use here a number 8 and here a number 3, if I multiplied minus 8 by plus 3, we will get minus 24. If I get minus 8 plus 3, we will get the minus 5 of the middle term. So that's the correct answer for this specific exercise. X minus 8 that multiplies x plus 3. So it's not difficult, it's only looking for two numbers that get algebraically added to get the middle term and multiplied, we will get the outside term. So let's continue with another exercise. So on the second exercise, we will get something like this, 64 plus m squared minus 20. So we need to order it, m squared minus 20m plus 64. Then I will open up two parentheses. When I open up two parentheses, remember, the square root, it will be on the two parentheses, then on the first parenthesis, I will put the same sign as the bx term. Now, minus to become a plus, we will need another minus. Now we need to look for two terms between them. When they get added or subtracted, we get minus 20. When they multiplied, we get a plus 64. Maybe in this one, it's kind of difficult to imagine some numbers. So what can we do? We can decompose by prime decomposition the number that we have on the outside part. So it's going to be 32, 16, 8, 4, 2, and 1. So we see here that it's 2 times 2, 5 times, not 6 times. So it's going to be 2 to the 6. So in this case, I need to look for a number. Maybe if I multiply these ones, I will get a 4. If I multiply these ones, I will get a 16. If I multiply the 16 and the 4, it's going to be 16 times 4, it's 64. And if I got minus 16 and minus 4, I will get minus 20. So this one is the correct answer for this specific exercise. So let's continue with another exercise. So let's check the next exercise. So on the next exercise, we got this one, a squared minus 10 minus 9a. So we need to order it. If I order it, it's going to be a squared minus 9a minus 10. So I will open two parentheses. Then it's going to be the square root of the first term in both parentheses. Then in the first parenthesis, we need the sign of the middle term of the bx term. Minus, to become a minus, we need a plus. So now we need to look for two numbers that when they get added, we get a minus 9. When they get multiplied, we get a minus 10. So it's going to be 10 and 1. Because if I multiply minus 10 by plus 1, I will get a minus 10. If I add minus 10 and plus 1, I will get a minus 9. So this is going to be the actual answer for this specific exercise. Let's see one other exercise. So let's see the next exercise. We have c to the 4 minus 2c squared minus 63y squared. So in this one, it's correctly ordered, but we have two letters. We have c and we have y. How do we do it? It's exactly the same. I will open up two parentheses. Remember, the first term will be the square root of the first term on both parentheses. Of course, it's not a perfect square trinomial because 63 doesn't have an exact square root. Then it's going to be this sign on the first parenthesis. Remember, minus to become minus, we need a plus here. Then we need to look for two numbers that when they get... Sorry, here I forgot a little bit. Here I must need a y and minus 63. So let's continue. We need the exact square root of the first term on both parentheses. Then what about the signs? The signs of the bx term, it's going to be first on the first parenthesis, then minus. To become a minus, we need a plus. Then we need to look for two numbers that when they get added or subtracted, we get a -2, and when they multiplied, we get a -63. But in this case, both numbers will also get a y, because we need that number to have a y when multiplied to become y squared. So in this case, 63 we can divide by 3. It's going to be 21. We can divide it by 3, and it's going to be 7. 7, it's going to be 1. So maybe we can have like a 3 times 3, it's 9. And 7, it's going to be -2. So it's going to be -9y plus 7y. If I multiply -9 times 7, it's going to be -63. If I add -9 and +7, I will get a -2. So if we got another letter here, the only thing that changes is that we need to add that letter, or well, the square root of that letter on both terms in each parenthesis. And that's going to be our actual answer of this exercise. So let's see another example. So imagine we have something like this, that it's very similar to the last one. We need to order our trinomial, so the correct order is going to be y squared minus 3y c squared minus 180 c to the 4. So how do we do it? Remember, we need to open up two parentheses. Of course, we know that it's not a perfect square trinomial because 180 doesn't have an exact square root. So it's going to be the square root of this one on the first and on the second term. What about the signs? The sign of the bx term on the first term, or the first parenthesis, minus, to become a minus, we need a plus. Since we have a letter here, we need to have the square root of that letter here and here. So now we need to look for two numbers that when they get added or subtracted, we get a -3 and multiply 180. What can we do? We can decompose the 180, and it's going to be 290, 245, 315, 3, 5, 5 is going to be 1. So we need to be a -3. So maybe we can like have 5 times 3, it's 15. And if we multiply this 3 times 2 times 2, it's 12. So if I multiplied a -15 by a +12, the multiplication will be -180, and the addition, or in this case subtraction, will be -3. And this is going to be our actual answer for this specific exercise.